All right, so let's get into a little bit of chemistry. We have to start with the basics. What is a chemical change? What is a physical change? What are chemical and physical properties? What are these things? Because they are foundational to everything we're going to do this year. So, first of all, let's take a step back and talk about the rarest, most unusual substance in the universe. Do you know what it is? It's water. Water is very, very strange, and yet it is the most important compound to life. Very little water has been found in the planets of our solar system. The Earth can be thought of as a water world. We are replete with water. There's a ton of water here. And water has some very unusual characteristics and properties that if they weren't that unusual, life could not exist on the earth. Actually, the way I think about it, water is made specifically by God to be able to be the substance around which he can build life forms. Water. We are indeed a water world. Here is something that is so strange and yet it is wondrous. You are seeing the three phases of matter. Now, it's not a big deal. It looks like a frosty morning, a little bit of fog there over the stream, and you've got some snow on the banks. So what? We have seen this maybe thousands of times in our neighborhood. Do you realize that you're seeing all three phases of matter at the same time? I know you can't appreciate this because you don't know that much about chemistry, but let me just tell you that is so strange. Water is one of the only chemicals that can exist in all three phases of matter like that at a pressure and a temperature that we as humans can live in. Now we can get all sorts of other chemicals to reach what we call their triple point, but typically it's at pressures and temperatures that we can't exist, or we can't exist in comfortably anyway. So, how much of the Earth's surface is covered by water? About 70%. And that's why I refer to the Earth as a water world. Is water ever entirely pure? No. The surface water has all sorts of dissolved minerals in them. Even distilled water, which is as pure as we can make water, will, as soon as you expose it to the air, will have dissolved gases in them. So you have probably never tasted, never drank pure water. Distilled water is as close as it gets. All right, so let's start with properties. Can you identify a property as physical or chemical? Let's see. First of all, get your notes out. What are physical properties of water or any other substance? They are those characteristics shared by all samples of a substance which can be observed without changing the identity of the substance. So, what do I mean by that? Take your teacher. She has brown hair. She has olive complexion. She has green eyes. She has two arms, two legs. We can mass her. We can determine her volume. We can determine her body temperature. There are many things that we can determine about her that would help you understand who and what she is. But if those things can change, but she still stays the same, it's a physical property. For example, she can maybe overeat for a couple of weeks and she could gain some weight. Is she still your teacher? Of course. She can change her hair color from brown to blonde. Is she still your teacher? Yes. Let's say that she has a temperature of 98 and then she catches a cold, and now because of the fever her temperature is 100. Is she still your teacher? Yes. All those things are physical properties. They're things that we can change about a substance without changing what it is. These can be considered things that can change about a material without changing what it is. For example, sulfur is yellow, malachite is green, sapphire is blue. Color is an example of a physical property. If the substance is a solid and then turns into a liquid, it's still bromine in this case. You can even convert bromine liquid into bromine gas. It's still bromine. The phase is a physical property. So, it's phase or state. How about taste? You can taste salt. By tasting it, do you change what salt is? Nope. Odor, you can smell sulfur. By smelling it, do you change sulfur? Nope. You can take a metal and shape it whatever shape you want it to be. By changing its shape, do you change what it is? No. And that's what I refer to as malleability. Have you ever played with Play-Doh? Play-Doh is a highly malleable substance. You can mold it with your hand with ease. Most metals are highly malleable. You can shape them into whatever shape you want them to be. Volume is the length and width and height. We talked about that last chapter. Ductility is the ability to take your Play-Doh and make it into a wire. When you were playing with Play-Doh, did you ever have a set that had a hole in it and you could push the Play-Doh through the hole and on the other side would come out a Play-Doh tube? Well, that's ductility. If you can make a wire out of it, you are ductile. You can actually change the density of different materials by adding heat to it. Does that change the material? Nope. So, what are chemical properties? So, let's, in our analogy, let's talk about your teacher. Let's see. We can talk about what would happen, wonder what would happen if we were to set her on fire. That would be terrible. Okay? If she was to be set on fire, what's left over, as sad as it would be, is it still your teacher? No, not really. What if we were to put her in a vat of acid? Oh, that would be horrible. Okay, what's left over, is that still your teacher? No. What if we were to expose her to some ammonia gas and just let her breathe ammonia gas? Would her lungs ever be the same after that? No. So you can change your teacher's hairstyle. You can change your teacher's eye color using contact lenses. That doesn't change your teacher. But if you're talking about having your teacher react with different substances and it radically changes your teacher and you never have your teacher ever again with you, that would be a chemical property. The properties of a substance that describe how it reacts with other substances to form new substances. You cannot observe these properties without changing the identity of the substance. And that is the key. Your teacher has become something new. All right, so let's look at some chemical properties. Now, what's really cool about that is that we can bring in some videos in order to see this. This man is going to be bubbling methane bubbles through some soap. So the soap will capture the bubbles, and then he's going to react those bubbles with oxygen in the air, and you'll see some pretty neat stuff.
One of the reaction types that you're going to learn about is the combustion reaction. Now, you've probably heard about combustions in automobiles where you combust gasoline in an engine to produce energy that makes your car go. And your gas furnaces at home actually combust gas to give you heat that heats your homes. Well, today I'm going to demonstrate a combustion reaction right in front of you. Okay, this is called methane bubbles. I'm just generating some methane bubbles right now. So that looks to be enough, so I'm just going to come over here and turn them off. Now, when we have a combustion reaction, we have to have what we're going to combust, which is the gas inside these bubbles, and we need an ignition source. So what I have is just a lighter here. I have some methane bubbles. I'm going to ignite them. Okay, so here we go.
So, in that reaction, what happened was the methane reacted with oxygen to produce two new things: carbon dioxide and water. In other words, it's not methane anymore. It's not oxygen anymore. It's two new things: carbon dioxide and water. This is perhaps the strangest chemical reaction I have ever seen. You're going to see this white powder. Looks like sugar, looks like salt. But once you react it with oxygen, it forms something amazing. I think they added the special effect, by the way. That sound is not natural. It sounds more like a snake's rattling. I think they added that just to make it sound neat. Isn't that weird? pH is going to determine how acidic or how basic something has become. If it becomes more acidic or more basic, it actually changes what it is. Flammability refers to its ability to burn in the presence of oxygen. Along with combustibility, you can almost think of those as synonymous. Reaction with acids. Once again, as acid is not something I've taught you about, I will teach about it soon, but it is a chemical that, if it was to react with many other chemicals, would form something new. Reaction with air. Nitrogen and oxygen is what air is made up of. If it reacts with either one of those, that would be a chemical property. So, what are the physical properties of water? Well, water is colorless, odorless, and tasteless. Yes, tasteless. Now, if you say, no, I like the taste of some waters, but I don't like the taste. Okay, you're not actually tasting water. You are tasting chemicals that are dissolved in water. If you were to taste water, it would taste yucky because it would have no taste. You would actually look at it and go, ew, this tastes terrible. Well, actually, it tastes like nothing. What is another important and physical property of water critical to plants? Water has high surface tension. Water sticks to itself very strongly. Plants make use of this in order to allow them to draw water from their roots to their leaves. Remember that Unlike us, plants don't have hearts for pumping fluids. So if water wasn't so strange and wondrous and could not stick to itself so easily, then water would not, well, we just could not base life on water. So now that we've had a close-up look at water, let's consider the types of changes that water can undergo. All reactions in chemistry are either physical or chemical. So what is a physical change? I wish I was in front of you. I would take up one of your sheets of paper and rip it in half. Okay, so now I have 2 pieces of paper. Have I changed it? No, I may have broken up into smaller pieces, but it's still paper. Physical changes involve a change in odor, a change in size, a change in color and phase, even geography, its location, but not a change in what the substance is. A chemical change, it always results in the production of a new substance. What the substance was once, it no longer is. It is a brand new thing. All right, let's look at some changes. So here you have 2 liquids, clear liquids, and as you can see, when they mix together, a brilliant yellow crystal is formed. The two liquids were potassium nitrate and lead to nitrate and potassium iodide. But when they mix together, they form lead to iodide. That's that yellow crystal. How about this?
Sticking in a bigger piece this time. Yep, lots of bubbles coming.
Dry ice.
And one thing you may...
Dry ice is solid carbon dioxide, and those big giant bubbles coming out of the solid piece of ice, that's just carbon dioxide. So carbon dioxide is going from solid phase to gas phase. It's still carbon dioxide afterwards, and it's carbon dioxide before. That's a physical change. That's a physical change. How about putting a piece of sodium in water? Okay, so the reason you have all these explosions is quite simple. Sodium reacts with water and tears water apart, and it creates hydrogen gas. Hydrogen gas is used as rocket fuel. So when the hydrogen gas reacts with the air, with the oxygen in the air, it produces that big giant explosion. What does it produce? It just produces water. So that's even another chemical change. So new things are formed. How about a piece of magnesium being ignited in the presence of oxygen? Bright light, and what's left over is a fine powder. If you were to analyze that powder, you would find that it is made up of magnesium and oxygen. So you had magnesium to begin with, you had oxygen in the air, and now together they've combined to form a new thing, magnesium oxide. All right, so I've mentioned the phrase chemical reaction a couple times. What does that mean? They are changes that involve the breaking and forming of chemical bonds, causing atoms to become rearranged into a new compound. Usually, new things that form have radically different properties from the compounds that form it. For example, you have here, let me get some black ink. You have here hydrogen and oxygen, and those big explosions that you saw, this is what's going on. Together, they will react to form two brand new things, water molecules. So that's hydrogen, that's oxygen, and that's water. Three completely different things.